All right, CalPC Unit 2, Day 2, Office Hours. So these are the problems from the book, page 576, 115 odd, 2731 odd, 35 to 38 all, 53 to 54, 59 to 64 all. So odds, you check in the back of your book. So these first problems say there's three parts, A, B, and C. Limit as x goes to infinity of f of x. For B, limit of f of x as x goes to negative infinity. C, identify all horizontal asymptotes, which I believe the parts A and B are going to help us find. So number one is fx equals cosine 1 over x. So part A is the limit as x goes to infinity of f of x, which is the limit as x goes to infinity of cosine 1 over x, which is going to give you cosine of 0, which is 1. B, limit as x goes to negative infinity. And that's also going to go to 0 on the inside. So that will also be 1. And so then part C, horizontal asymptotes. Will be y equals 1. So there you go. I could zoom in a little bit. I'm trying to write small so I can put a lot of these on here. 3 function is e to the negative x over x. Now, I think I'm going to rewrite this as 1 over x e to the x, which I think will make it easier to figure these out. So, part A, the bottom is going to blow up. It's going to go to 0. You divide by a huge number, it's 0. Negative infinity. Now, this is interesting because if we go to negative infinity, that's the same. E to the negative infinity is going to be e to the x on the top, e to the infinity on top, positive infinity. This is going to be negative infinity at the bottom. So it's going to be a negative answer. What's growing bigger, an exponential or like a linear? Exponential dominates. So this is going to go to negative infinity. Yeah? Negative infinity. So that one was a little interesting. So C, horizontal asymptotes are just going to be y equals 0. You should have the y equals as part of it. Okay, number 5. F of x equals 3x plus 1 over the absolute value of x plus 2. So part A. Is going to be, now if you just plug them in right now, it's going to be infinity over infinity. So the dominant terms are here. Be positive, absolute value is going to force it to be positive. So it's just going to be the ratio of their coefficients, which is 3, right? Now, when we go to negative infinity, the dominant terms are the same degree as each other, but the top's going to be negative and the bottom's going to be positive. So we're going to get negative 3. So that's a little tricky situation. So there are actually 2 horizontal asymptotes, different for each side. Yeah? let's see. And last one of this kind of problem, 7. A similar type of thing. Might decide to cut this one out because it's the same kind of problem. So those are the dominant terms, the same degree. If you got a positive, it's just the ratio of the coefficients 1/1, which is 1. And B, go to negative infinity. Those are the dominant terms, but it's going to be negative or positive for sure. So it's going to be negative 1/1. So it's -1. And so then the horizontal asymptotes are y equals 1 and y equals -1. 2 answers. Okay. Now, the next problems say to find a limit and confirm your answer using the sandwich theorem. All right. So, got to use sandwich theorem. This is 1 minus cosine x over x squared. Now, if we, if we just thought of this as like this is the dominant term, top doesn't really have, this isn't really a dominant term. It just goes between -1 and 1. But I think it's going to go to 0. But we could show it with sandwich theorem. So we start with 1 minus cosine x is between, now it's not -1 and 1. This would be -1 to 1. But think what's the smallest value you could get? Well, if this is +1, that's going to be 0. If this is -1, that's going to be 2. Right? So then we divide everything by x squared. And I mean, essentially that's just 0. I mean, we don't even, whatever x is, as long as it's not 0, well, now, yeah, well, okay. So as x goes to infinity, that's going to be 0. That's going to be 0. So the whole thing has to go to 0. I think that's, so I mean, usually we say since limit as x goes to infinity, 0 over x squared equals the limit as x goes to infinity of 2 over x squared equals 0, then the limit as x goes to infinity of 1 minus cosine x over x squared equals 0. So that would be kind of the way to write that. 11, another problem like this, limit as x goes to negative infinity of sine x over x. Now, I'm going to say just analyzing this is in between -1 and 1. It's just going to be some number. Now it's going to be huge. It's going to go to 0. Now to prove it, we start with this. Signs between -1 and 1. And divide everything by x. Right? And then say, well, as x goes to negative infinity, this is going to be 0. And that's going to be 0. So since the limit as x goes to negative infinity, -1 over x equals the limit as x goes to negative infinity of +1 over x, both go to 0, then the limit as x goes to infinity of sine x over x must be 0. So there we go. Okay, next problem's, we're going to just find limits. 13 says limit as x goes to the right. Now, what I like to do here is to be like, okay, well, that's going to be 1 over 0, so it's going to be some kind of infinity. Technically does not exist, but is it positive or negative? So you think, well, here's the 2 plus, right? And that means something a little bigger than 2 because you're coming from 2 from the right side. So that's going to be a positive, tiny number. So that's got to be positive, right? So that's how I would do that. 15 going to negative 3 from the left. So plug negative 3 in here, it's going to be 1 over 0, so it's going to be some kind of infinity. But approaching negative 3 from the left, so that's going to be like, to the left of negative 3 would be like negative 3.0001, more negative. So this is going to be negative, and this is going to be negative. Okay. All right. So jumping to 27, 29, 31, these say, part A, find the vertical asymptotes. B, describe the behavior to the left and the right of each vertical asymptote. Okay, so 27, the function is 1 over x squared minus 4. So to help find vertical asymptotes, probably want to factor this, make sure we don't count any holes. So part A, vertical asymptotes, going to be x equals negative 2 and x equals positive 2. Now, it says on each side, left and right sides, vertical asymptotes. So vertical asymptotes, usually the graphs blow up, right? So let's see, at x equals negative 2 on the left-hand side, and just think, if you plug in something to the left of negative 2, that'd be like negative 2 point something. That's going to be a small negative number, right? And that's going to be just negative 4. And so it's going to give you a positive. It's going to go to positive infinity. And the right-hand side would be like negative 1.999, which would make this positive and this negative, and you'd get a negative result. And then at positive 2, left-hand side, positive 2 would be like 1.999, which would be positive, negative. It's going to go to negative infinity. And the right-hand side would be like 2.0001 would be positive, tiny positive. It's all positive, positive infinity. So that's the way I would do that. I mean, you could graph it, see, but that's something you should be able to kind of look at and be able to tell. All right, 29. So I'm going to factor the top, right? So vertical asymptotes, which is going to be x equals negative 1. That's it. Okay. Now at x equals negative 1, the left-hand side behavior would go to what? Now, as you approach negative 1 from the left side, this is going to be like negative 1.0001. This is going to be all negative on the bottom, negative on the top, negative. Negative times negative is positive or negative. It's all negative. It's blown up, negative infinity. Right hand, it's going to be like 1.0001. So it's going to be, or negative 0.9999. So that's going to be positive, negative. There's no negatives, positive. It's all going to be positive. It kind of makes sense that usually pretty much always the asymptotes, the function blows up in one direction or either, unless there's multiple asymptotes with the same value. All right, 31. F of x equals cotangent x, which is 1 over tangent x, and tangent side of a cosine, so this would be cosine over sine. So vertical asymptotes are going to be whenever sine equals 0, right? Because that gives you division by 0, so that's going to be when x equals 0 plus pi k, where k is an integer. So part A, vertical asymptotes, are going to be at x equals 0 plus pi k, where k equals an integer. Now, from the left side of each of these, because there's infinite ones, we could probably just do the left-hand side of one of them. So, like when you're approaching 0 from the left, cosine is positive in the fourth quadrant. Sine is negative, so it's going to be negative result. And from the right-hand side, coming towards 0, cosine is positive, sine is positive, so the overall answer should be positive. And we know it's blown up because there's vertical asymptote. So there you go. All right, next chunk is 35 to 38. So 35 was y equals 2x cubed minus 3x squared plus 1 over x plus 3. And these ones, I'm going to actually write them all down. It says match the function with the graph of its in-behavior model. So let's go ahead and just write all these down real quick. And then we'll talk about how to identify their in-behavior model. And I'll even sketch the graphs real quick, because it'll help make a lot more sense. So I'm just writing these problems down. Okay, the graphs, A kind of looks like a parabola. It's probably good enough. And B looks kind of like a cubic, maybe. And C looks kind of like a upside down cubic, like a negative cubic. And D, oops, I think I did this wrong. Sorry. This is actually C. So I did these in the wrong order. This is C, this is D, and then B, which I accidentally skipped, looks like an upside down parabola. All right, sorry. It would have been nice if I put them in order. So on these problems, the in behaviors, as you go to infinity, positive or negative infinity. So you're looking at the dominant terms on the top and the bottom, and then like we showed in the lesson, essentially the graph behaves like that. And if it's going to behave like a parabola opening up. So this one, that's got to be A, right? And this one, dominant terms would be x to the fifth and 2x squared, which means that the graph, the in behavior function, is going to be x to the third over 2. So that's what we're talking about, in behavior function. So that's a cubic. So that's going to be C. And here's the dominant term. So the in behavior function is going to be negative 2x cubed. So that's like an upside down cubic, which is D. And here, those are the dominant terms, the top and bottom. So the in behavior function is going to be x to negative x to the squared. Upside down problem. B. So it's kind of easy. Okay, 53 says find the limit f of x as x goes to negative infinity, positive infinity, 0 superscript negative d superscript plus. And give you a piecewise graph. So I'm going to do a sketch of it because I feel like answering the question would be a lot easier with a sketch. Even though I think we could probably get away without it. But let's see. So A, the limit as x goes to negative infinity of f of x. Well, which one's defined for negative where negative infinity? It'd be that one. So it's going to be 1 over negative infinity, which is going to be 0. Right? And then B, limit as x goes to positive infinity. And say, well, which one am I using? You say, oh, well, it just goes negative 1. You go to positive infinity. C, limit as x goes to 0 superscript minus. Well, which one is it defined to the left side of 0? That one. And so it's going to be a really small negative value, like negative 0. So it's going to be negative infinity. And D, you say, okay, well, we're going to approach 0 from the right side. Its value is going to just be negative 1 on the right side. So that's it. You can draw a sketch of this if you want, but I think you can figure out even without a sketch. The sketch looks like this, by the way. It's a rational function, and then it's like a horizontal line. So the left of 0, it's this guy. And add 0 to the right of 0, it's this guy. All right? That's what that piecewise function looks like. Okay, 54. So A, limit as x goes to negative infinity of f of x. So on the negative side, you'd be looking at these guys' dominant terms. Ratio of their coefficients are both going to be negative, so it's going to be essentially negative infinity over negative infinity with the same size terms. It's going to be 1. B, positive infinity, it's going to be this guy, and that's going to go to 1 over infinity, which is going to be 0. C, approaching 0 from the left-hand side, so it's going to be this guy right here. And so you're plugging really tiny numbers in here, essentially negative 0.00001. So essentially it's going to be negative 2 over negative 1. Those terms are like nothing. So the answer is positive 2. And then D, as we approach from the right side, it's going to be this. So it's going to be like 1 over a positive, very tiny positive number. So it's going to go to positive infinity. So, anyways, there you go. All right. And the last chunk of problems, 59 to 64. There's some true false problems. 29 says true or false. Is it possible for a function to have more than one horizontal asymptote? Justify. Well, more than one horizontal asymptote. True. You could find one of these examples that we did that had different horizontal asymptotes on each side, like number 5. You could just say, well, if fx equals 3x plus 1, over the absolute value of x plus 2, then limit as x goes to negative infinity is negative 3, and the limit as x goes to positive infinity is positive 3. Seems like good justification. 60, if f of x has a vertical asymptote, so vertical asymptote at x equals c, then either the limit as x approaches c negative or c positive is infinity, or it's negative infinity. So they're saying that if you have a vertical asymptote, it's definitely going to be infinity or negative infinity. I don't know. I would say they're saying limit as x approaches c negative f of x equals limit as x approaches c positive equals infinity or negative infinity. I want to say true, because they're saying they're either, well, no, I don't know. I think what they're saying is they're either both infinity or they're both negative infinity. I think that's actually false, because usually that's not true. Usually one is one and one is the other. So they're lumping these together. They're saying they're either both positive infinity or they're both negative infinity. So like an example would just be like y equals 1 over x minus c. Well, limit as x approaches c from the left-hand side is going to be something, let's say it was like 4, it'd be like 3.999. That's going to be negative infinity. And the limit from the other side is going to be positive infinity. So there's a counter example. Let's see, 61's multiple choice. Limit as x approaches to negative of x over x minus 2. So I'm just going to treat these like non-multiple choice problems, and then hopefully the answer's there. So this is going to be like doing that, which is like approaching 2 from less, that's like 1.999, just as an example. So it's going to be 2, positive 2. That superscript negative has nothing to do with it being negative. Over a small number that's going to be negative. So it's going to go to negative infinity. All right, which is option A. Okay. And then 62, limit as x approaches 0, cosine 2x over x. Now, if we just plug 0 in, we get 1 over 0, right? So it's definitely going to some kind of infinity. If you approach from the left, it's going to be negative infinity. If you approach from the right, it's going to be positive. So it depends. Now, technically, the answer is does not exist. So if you look at the answers that you have available to you, infinity is not one of them. Does not exist is, though. So that's E. Sometimes they say non-existent. 63, limit as x approaches 0 of sine 3x over x. Now the trick here is to try and get that sine x over x pattern if you're going to 0. So whatever's here needs to be down here. So we need to add a 3 there, which we can do as long as we multiply the top by 3 too. So that's going to be 1. So it's going to be 3 times 1 is 3, which is answer C. 64, which the following is an in behavior for f of x equals 2x cubed minus x squared plus x plus 1 over x cubed minus 1.